There we go. Okay, your next deliverable is an architecture design document. Now, this is a very short-term project. You have 1 week to do this. I'm not expecting much. But what you will find is that, as you have said, with each of your deliverables, as we talked about last hour, earlier this hour, with each of your deliverables, as you do them, you go back and question what you did earlier. It's kind of like, okay, here's our org chart. Now we're doing requirements. Uh-oh, here are some things we need to do. So maybe we'll make some changes to our org chart. Though a lot of you are rather small teams, so there's not a lot of changes you can make, period. And then you did your PERT and Gantt charts, and as some of you said, and we had to rethink what we were doing. We suddenly realized there were tasks that we didn't have down, or concepts we hadn't thought through. You're going to have the same experience as you do your architecture and design document. What is architecture? Boy, this is a question that the software industry just wraps around the axle. Fundamental organization of the system to be constructed with a focus on connections and interfaces among subsystems. That's probably as good as anything, but architecture also comprises prioritizing. What aspects? Does this have to be fast? Does it have to be error-free? I worked on the Space Shuttle flight simulators at NASA. Space Shuttle, and this was before the first Space Shuttle launch. Space Shuttle had a very interesting ultra-high redundancy architecture to avoid failure, because you don't want the Space Shuttle blowing up on, the pad. What you had in the Space Shuttle is you had 4 computers made by IBM. That's a B. All running identical software. Literally the same copy of the software. And they all fed into a selection gate. And so when they had something they had to signal or control, they took a majority vote. So if you were getting 3 signals from 3 of the computers and 1 signal from one of the others, and these were almost always binary votes, so it's not like you could have multiple versions, it would go with the majority vote. So wait, you say, there's 4, what about a tie? There was a 5th computer developed using the same specifications, but developed by, I think it was Lockheed. And it was a tiebreaker. So if you got a 2 and 2 vote from the 4 IBM, then go with whatever the Lockheed software said. This was ultra high quality software. The irony with all this is that the first Space Shuttle flight was 48 hours late taking off. And the problem, I actually know, my office mate, by then I was no longer working at NASA, I was working at Lunar Planetary Institute next door. Carolyn, I shared an office with. Her husband was a programmer at IBM who found the problem and delayed the first shuttle flight. What it was is that, and actually my responsibility, let's say this is Kennedy Space Center. There's a computer called the Launch Processing System. Let's draw. That has control of the space shuttle and all its systems until 30 seconds before launch. And then it hands it over to these. The problem was there was a subtle software bug such that there was a 40 millisecond difference in the clocks between here and here. And they could never agree on what time it was to actually hand things off. And it delayed it. And Carolyn's husband was the one who tracked down the bug on the shuttle side and fixed it and got a $1,500 bonus, which was pretty nice because at that time I was making, let's see, how much was I making it? I was making probably about $20,000 a year, so a $1,500 bonus like a month's salary for fixing that. Anyway, so you can have something where the critical issue is quality and safety. It can be performance. I keep talking about pages. People will not tolerate too long a delay between when you hit a key and when that letter appears on the screen. And we spent a lot of time optimizing that loop. And doing some ugly things under the hood. It's kind of like, we're putting all this in a box, we're just not going to look too closely at it, but it's really ugly stuff to make sure that when that keystroke gets hit, we get that key up on the screen as quickly as possible. It can be functionality. It can be cost. The shuttle software was at that time the most expensive software per line of code that had ever been developed. If I, on the other hand, am doing an app which I'm going to push off onto the internet and hope that people download, I can't afford a large cost per line of code. It's basically me in my garage or attic or office or whatever, putting stuff together. The fundamental structure or environment of the solution in other words, what is going to allow you to settle on all this? And then it requires, this is so important. Tom Affinito was at, mentioned it before, Intelligent, which was this big object-oriented operating system environment that was in theory being developed for HP and Apple, and I still have about that many technical manuals on it. It failed. But he said this in a conversation I was having with him. He said, architecture is a political act. And that's the thing a lot of chief software architects don't realize. A lot of architecture is going around and doing one-on-one conversations with engineers and getting buy-in on the approach, listening to their feedback, and then going to the next engineer and echoing your revised feedback, and then going to the next and doing the same until the engineers all agree with the approach you're taking. It is a political act. If you find yourself as a chief software architect, recognize that your single biggest challenge is basically to build consensus among your team. And if you approach it as, Moses coming down from Mount Sinai with the tablets, you will get passive resistance at best and active rebellion at worst. Any comments, questions, observations? Any of you seen this? Have any of you actually been in a position where you've in essence had to be the chief software architect for a system? And what's been your experience along these lines?
Our biggest problem is just student turnover. So you have 2 or 3 students working on a job, and then one gets an internship, and then the other gets another job, and then you got to hire new students, and then they don't know the language or the architecture, and it's a lot of projects that get handed off and end up pretty poorly. Yeah,
and that's a problem. If you have a high degree of turnover, and this is why, and we'll talk about this as you can get more into peopleware. Why you want to keep your people happy. One of the things I am proudest of at Pages was how hard I fought for the engineering team, and the fact that we had, in 5 years, we had 0 voluntary turnover. There was one person I hired early on, one of my earliest hires, who I fired because he turned out not to be the person we needed, and I kept asking him to do things. We're still in early stages, and I'd say, go think deeply about this, and he'd come back 3 days later with a piece of paper and said, well, no, this isn't really thinking deeply about it. And after about a month of that, I finally just let him go. We had one other developer who, after a couple of years, was fired just because he had some personal issues and problems that were becoming more and more destructive at work. And we had a couple engineers who were laid off about 3 to 6 months after we shipped because we just weren't getting the sales we needed because there wasn't the install base. No one quit voluntarily. And that's one of the things that I'm proudest of professionally, and part of it is because I fought for good tools, good environment, offices with doors, basically the things necessary to keep them happy. One of the earliest fights I had, by the way, as we were starting to close on venture funding, the investors wanted to move the company from San Diego up to Silicon Valley. And I said, no. I said, absolutely not. I said, and here's why. Go up to Silicon Valley. This is 1990, so it's still early days. But even then, I actually had just come from living up in Silicon Valley for 2 years. I said, if any of them are the least bit unhappy, they can walk out the door and have half a dozen job offers. I said, down here in San Diego, there's a higher energy cliff you have to scale to find a comparable job. I said, we're going to have a high degree of turnover if we move up to Silicon Valley. Plus, it's far more expensive to live, so on and so forth. I like San Diego a lot better than Silicon Valley. Anyway, and I attribute our lack of turnover in part to that. Okay. To be architectural, like I said, boy, I've got half a dozen books on software architecture. No one can quite agree on what software architecture actually is. Other than sort of, well, I'll know when I see it. To be architectural is the most abstract description of the company that enables reasoning about critical requirements and constraints and all subsequent requirements. That's a nice one because that's basically saying it's an abstract description, but it encompasses our entire solution. Now, does that tell you what to put into a document? Oh, no. Typical aspects of a software system architecture. Define it. Remember the 3 diagrams? Define the system in terms of computational components and interactions. So that's the diagram I put up, said here's the major subsystems and here's who talks to what. Shows the correspondence between system requirements, the elements of the construction system, and clarifies the structural and semantic differences. I'm not even sure what that means. And this is quoting from a textbook on software architecture. The point is that you want to show how it's put together, what things mean, and what the implications are when you actually start doing design and implementation. In other words, your architecture should be a roadmap to design and implementation. Another book, Spinrad. Top level design, functional, physical, and operational. Now I like this, the how. Creative, obsessive juggling of requirements, constraints, technology, costs, and standards. That's the software development process. A lot of you are going through that right now. You're looking at requirements and saying, oh my gosh, you've got to do this. And then you look at your schedule and say, oh my gosh, here are tasks we didn't think about. They're part of the requirements too. Who's going to do them? So now you're looking back at organization. That should be base, not based. Create an enduring base for growth and change. Again, one of the reasons I'm so proud of the Pages architecture is because we were able to very rapidly add new functionality. It was a very robust architecture. It was very clean. It lent itself to modification. Okay. What your architecture should include. This first one is important. Why will people love your app? That's got to drive the rest of your architecture. Now that sounds sort of like a requirements thing. But requirements is what you're going to build so your customers will love your app. Why would anyone want to use what you're building? What would make them pick it up and say, wow, I've got to have this. This is a cool app. Now, understanding that your target market may be small, In other words, you may be building an app that's only designed for 1% of the population, but what would make them say, this is so cool, I have to have this? How many of you had that experience of seeing an app or a software program or a game or even a piece of hardware and you look at it and say, oh, that's so cool, I've got to buy that? That is an essential part of architecture because your architecture has to be geared towards achieving that effect. The what, okay, here's, in terms of an actual diagram, all I'm really asking for is a top-level diagram showing the major subsystems and interactions among them. Given that you have 1 week to do this, given that you're pushing ahead on all sorts of fronts right now, I'm not expecting anything terribly complex. But I do want something that actually is a reflection of what you've already done in terms of your requirements. Talk about what trade-offs and choices you are making. We're using this language, or we're aiming for this platform, or we're using this particular engine or library because X. And now you talk about how your design and your choices will delight the customer. We are using this technology, and we're focusing on this aspect, performance, nifty graphics, whatever, because we think that's what will really jazz the customer for our product. Again, this doesn't have to be terribly deep, but it should reflect the thought of what you're doing. Design is your specific solution implementing architecture. You can mandate or prohibit. You look for opportunities for design reuse. And this covers a wide set of areas. And I'll have these slides up today. The videos may take a little longer, but I'll have the slides up so you can go back and look at this. So, you've got UX UI design, you've got your database design, patterns and module interfaces. I talked about deep interfaces, coding standards and guidelines. I happen to think that coding standards, this is a contentious issue in the software industry. Yeah, they keep wanting me to format it a certain way. I was the coding standards, what's the word I'm looking for? Guru, not guru, more like executioner. 10 pages. We had 8 programmers working on 500,000 lines of code. In a large, complex system. I would go through other people's code and ensure that it was meeting the coding standards I had set up, because it minimizes communication issues. If you get used to seeing code formatted, how many of you have had to pick up a piece of code that someone else wrote, and one of the first things you do is reformat it, rename routines, actually give meaningful names. Why do you do that?
So I can understand.
Yeah, so you can read it.
Work with it.
Yeah, yes.
Also to kind of load it in your head.
That does a lot too. That's actually very important. It's why I often end up doing that when I'm doing source code analysis on some of my projects. Yeah.
I feel like it interferes with my ability to think about the hard parts if I'm having any sort of challenge
Yep.
as I'm looking at it.
And that is the key reason why you have coding standards and guidelines. You want to minimize people tripping over, logs you left in their way. You want to pick it up and say, I know how this is supposed to be formatted, and I can sort of ignore where the semicolons are or how far the indents are, whether it's tabs or spaces, whether it's camel case or something else as far as the naming conventions, and I can just read the code. You don't have to have coding standards in your projects, but if you do, good for you. Last item there, design deliverables are often dependent upon methodologies. A lot of methodologies have specific design deliverables that they want you to create. So here's a suggested approach. I'll get this up quickly so you can all make use of this. But again, feel free to go back to the wikis from previous semesters, look at their documents, steal their documents, You know, erase their stuff and just use the same headers and structures if you like it. That's the best form of reuse. And I'm especially interested in this last item. I want to know what you see as the hardest problems and how you're going to tackle them, and in what order. Some of you have already started to identify some of those in your status reports. Good for you. This is such a critical issue in software development, and it is so badly neglected in the real world. Everyone goes for the low-hanging fruit. Everyone hunts on hard problems. And then it gets really ugly when you think you're 90% done and really only about 50% done. No one can quite figure out why. So this should be on your Teams wiki by Saturday midnight, Monday afternoon. I may have each team's architect stand up to just basically give a 2-minute explanation. This is what we're doing and why. Don't forget your status report and podcast by midnight Saturday. Greetings for next week. Fairly constrained. 2 chapters on Mythical Man Month, 2 out of Peopleware, 1 out of Accelerate. Webster Readings number 5, which I forget what it is. Any questions? Yeah, guys. Hour and 15 minutes. So, oh yeah. Any question?
So for the perfect Gantt charts, you have examples in your slides. Do you have anything like that for the architectural documents, or?
No, but as I said, if you go back to the previous wikis, I'd go through 3 or 4 of them, look at them, and decide what you like, or just take the best you like out of each one. See which ones. Here's a good thing to do. Go back to say the winter 2019 wiki. Go through the projects, look at each of their architectural documents, and see which ones spark joy in you. and which ones you look at and say, oh, that's lame. Okay? And then focus on just, copy and reproduce the ones that spark joy. Look for the ones that you look at and say, this is so cool, I like how they did this. So, that's it. Okay? See y'all in a week. Have a good week.